This is a second video for April 22nd assignment for intermediate algebra on 11.2 through 12.5, just bits and pieces from different sections and leaving out some sections. 11.5 is about parabolas that are in standard form where you can tell, and when we talk about a parabola it's going to look like this, a U-shaped graph. You can tell the vertex, and the vertex is a very important point. It's this point right here where it turns. It's going down here, then it starts going up. That's the vertex. When they're in standard form, you can tell where the vertex is by looking in the parentheses. What makes that 0? 6 makes that 0. So the x-coordinate of the vertex is 6. Then you put that 6 back in there. 1 is the y-coordinate that goes with it. So this point right here, the vertex is 6, 1. What we need to do is find points on both sides of that vertex. To the left of it, we're going to have 5 and 4. To the right of it, 7 and 8. 5 and 7, notice, are just 1 point either way from the 6. 5 is 1 to the left, 7 is 1 to the right. I put both of those back in the original equation. 5 minus 6 is -1, squared is 1, plus 1 is 2. Same way with 7. 7 minus 6 is 1, squared is 1, plus 1 is 2. Then I go to 4 and 8, the same way. Put those in the original equation. 4 minus 6 is -2, squared is 4, plus 1 is 5. 8 minus 6 is 2, squared is 4, plus 1, 5. Then I plot those 5 points, and I have the parabola. Now we're going to look at that parabola and talk about some things. First, the x-intercept. Where does it cross the x-axis? It does not. So this time there's no x-intercept. Second thing, y-intercept. Well, it will keep going up and eventually cross this y-axis. Eventually. To find a y-intercept, you put 0 back in the original equation for the x. 0 minus 6 squared, that's -6 squared, is 36 plus 1, that's 37. So 0, 37 is your y-intercept. And we know it's there, but we won't graph all the way up there. Our domain, look at our graph here. Does it ever stop as it goes left and right? No. So the x's, that's what domain is from -infinity to infinity. And another thing to look at is our original equation. Is there any x's in the denominator? No. So our domain is all real numbers. Our range is the y-coordinates. Looking back at our graph. What's the lowest y-coordinate? It is 1. So our range starts at 1, bracket 1, and goes to infinity. That is briefly talking about parabolas. Then we go to 12.1, which we've done some on here before. This is first, we're going to add the two functions together, as shown here. Nothing can be simplified. Then we're going to subtract the first one minus the second one. Notice minus that second one changed the two signs in the parentheses there, like this. Then I multiplied this cube root of x times x minus 3. Remember, cube root of x is x to the 1/3 times x and times the -3. So x to the 1/3 is times an x, which means x to the 3/3. So we get 4/3 when we add our exponents. Then x to the 1/3 times 3, we get this. Dividing them, we have this. The next 14, we are doing composite functions. On number 14, we are asked to find h composite of G of 0. And this means h of G of 0. And so in math, we start at the inside. G of 0 means that you put the 0 in the G function. Negative 2 times 0 is 0. So G of 0, negative 2 times 0, back up here, that's what this means. Put 0 in for the x in the G of x. So negative 2 times 0 is 0. Then h of 0 means you put the 0 in for the x in the h of x. So the square root of 0 is 0. So our composite function, h, composite of G of 0, is 0. Then, the little more standard use of the composite functions, we find f, composite of G of x, and then we turn it around and find G, composite f of x. Here are my two functions. X minus 3 is the f of x. X squared is my G of x. The first one we're going to find, FOG, f composite G of x, means the first thing we do is the G of x, we look back and it's x squared. X squared is what G of x is. So then that x squared replaces G of x right here. So we have f of x squared. That means we put x squared in for the x up here. So x squared minus 3. And another way of looking at it, when you're doing this composite function, you take whatever the G of x is, this, and put it in for the x over here. Same way on the second one, just reversing it. G, composite of f of x. F of x, or it's G of f of x. First thing we do is we take whatever f of x is, and it's x minus 3. So that x minus 3 is put in for the x on the G of x. X minus 3 goes in here for x and is squared. So we have x minus 3 squared. And if you FOIL that out, we get x squared minus 6x plus 9. Then 12.2 deals with inverses and one-to-one functions. Number 1, we've got this function written right here. It's a function because the x's do not repeat. Do not repeat the x's. That's why it's a function. We ask, is it one-to-one? We look at the y's. Do they repeat? No. So it is one-to-one. So yes, it's one-to-one because the y's did not repeat. So what we can do is write the inverse. This f with a little -1 as its exponent is meaning the inverse of f. And it's hard to tell what I've done here, but I've taken the original ordered pairs and just flipped them around. Now on the third one you can actually see it was 0, 2, it becomes 2, 0. On the last one it was 2, 0, now it's 0, 2. That's how you write the inverse, by flipping the x's and y's around. Number 2, we have a function right up here. I ask, is it one-to-one? I look at it right there. Those two y's repeat themselves. So it is not one-to-one. So I cannot write an inverse. Number 3, we have the ordered pair 10, 10. Well, just one ordered pair, so yes, it's one-to-one. The y's can't repeat when there's only one y coordinate. So what is the inverse? I turn it around. This 10 here becomes the x coordinate. This 10 here becomes the y coordinate. So the inverse of h is 10, 10. Number 4, we look at this function. Here we look at the y's. None of them repeat. So it's one-to-one. None of the y's repeated. So it's one-to-one. The inverse is, look at those. I turned 1, 2 around to 2, 1. 3, 4 around to 4, 3. 5, 6 to 6, 5. 6, 7 to 7, 6. Number 6, we have this function given. It is not one-to-one because look at those two y coordinates. They repeat. So I can't write any inverse. Then, getting a little fancier with our functions, we have a function January 5.7, and like this, I abbreviated. Number 8, I had at Texas at 70, Massachusetts 22, I think Nevada 3, and a state with an I 3, and Wisconsin 31. Is it 1-to-1? No, because these two states had the same y coordinate, not 1-to-1. Okay, number 9 is written here. I abbreviated what they were. But number 10, we have a triangle is 3, pentagon 5, quadrilateral 4, hexagon 6, decagon 10. How many sides they have? Well, the 3, the 5, the 4, the 6, and the 10 are our y's. They do not repeat. So our inverse is turning those around. Turning those around. We use that again down on 11 through 14. We have this as our function, f of x equals x cubed plus 2. On number 12, I'm defined f of 0. That means I put 0 in for my x. So f of 0 equals 2. In other words, the ordered pair, 0, 2. And then, if I'm asked to find my inverse of that 2, it's 0, because look here, I had the ordered pair 0, 2. On your inverse, you have 2, 0, don't you? Flipping those around. So the f inverse of 2 equals 0. In other words, just turning this around. Number 14, f of negative 2, I put negative 2 in, cube it, negative 8 plus 2, I get negative 6. So f of negative 2 equals negative 6. So my inverse is flipping those around. The negative 6 goes here, the negative 2 goes here. F inverse of negative 6 is negative 2. Then, on logarithms, this is just simply rewriting these. Number 1 is right here. Okay, number 2, the log to the base 2 of 32 equals 5. That's log form. Log to the base 2 of 32 equals 5. That is rewritten as 2 to the 5th equals 32. This 2, this is the exponent of that base. 2 to the 5th equals 32. Number 4, log to the base 5 of 1/25 equals negative 2. So this 5 to this negative 2 is the exponent, equals 1/25. Number 6, log to the base 10, so that 10 goes here, of 10 equals 1, so this 10 to the first equals 10. And by the way, this is called your common log, base 10, so sometimes if there's no base written there, it's understood to be 10. Number 8, log to the base 8 of y equals 7, so 8 to the 7th equals y. Number 10 is a special log. Log to the base e of 1 over e equals negative 1, so this e to the negative 1 equals 1 over e. E is not a variable, it's called Euler's constant. It is approximately 2.7, kind of like pi is 3.14. Well, e is about 2.7. Log to the base e is abbreviated ln, meaning the natural log, and you've got that button on your calculator. Number 12 comes out this way. Number 14 and 16 are written this way. That concludes this video.